We are discussing category of machine learning, supervised, unsupervised, and reinforcement. So we will be having a labeled data set is supervised, and direct feedback is there, prediction outcome feature is there. Unsupervised has no label or target value, and no feedback is there, find hidden structure in data structure. And that is done by the finding a similarity between data set. Reinforcement, direct processing, reward system, and learn series of action. I hope you get the idea on this. Now, supervised learning has pattern, so regression and classification is there. And classification, we basically classify two classes. So you can see we have plus and minus, and we are just creating a line in between, and we are having two classes now. This is kind of division is called classification. Regression, on the other hand, we have a straight line and we have points over it, and we try to find out, the distance of this line from this particular line, and this is how regression actually get implemented. And unsupervised learning, classical string just have this similarity basis division. So we simply have all the elements and we find similarity between divisions. You can say the classes, and you can say element also. So these class elements are find as per the grouped in case of by finding a similarity between them. And once the similarities are there, we group them in group A, B, and C. Now again, we will be deciding how many groups we want to create. That is how this algorithm really works. We will discuss this later when we go for the clustering algo. Unsupervised learning, we have dimensionality reduction. So we have this dimension in 3D. What we do, we reduce the dimension and we put it to 2D. Now again, it is in unsupervised, not really, but it is in dimension reduction technique. And as you can see, creating or drawing a line at the moment is very hard. If you've seen 3D, we cannot really create a line to divide. That is not practical. If we do one thing, the wrong classification will be done for other, which is not that much practical. But here, classifying is way too easy, and that is what happens when you reduce the classes, the dimension, and that is what we plan to do with PCA or dimension reduction techniques. Reinforcement, we already discussed that we have a reward and punishment system. So whenever the coding has printed correctly, we call it give it a reward. So it's just a counter basically. We have a counter, and this counter increase its value and decrease in value. So suppose we have 1, then 2, then 3, and so on. And the value decrease, we have -1, then -2, and so on. It keep reducing if the punishment is there, that is wrong quotation is there. When you do it right, the increment of the counter goes on. Next, we have a simple regression problem. Now we will start regression from this point and we'll discuss dedicatedly regression problem here. So in regression, the main thing that we need to understand is that we have a straight line, okay, and this line is what we are plotting by the model. Now, guys, these element you see, it is the plotting. All the data set that we have, all the features that we have. Now, features is basic data set column only. All the columns that we have and the values that we have as per the x and y coordinate, we plot that value. We are plotting all the values here. Once we are done with this plotting, we try to draw a line in between in such a way that this line is least amount of error, and that error is the distance from this point. It has least amount of distance. Now that means, guys, we are calculating the distance from this line from this point. Each and every point will be calculated how far it is from this line. Okay, every point will be calculated there, and the amount of error, this distance that we are getting, is called our loss. Okay, it's called our loss, and the amount of loss should be as low as possible. So it should be as less far away as possible, and that is how linear regression really works. I hope it makes sense. Now in regression, we call it residue. So that is total distance is called error, and we add all the distance, all the error, and we call it residue. It is called residue. Okay, and total error is also a terminology for this. We count this. We simply find out the loss that we are having all of the point should be very close to it, and we try to put a line which is least amount of away from the this point. Now guys, what we do next is the initial stage of this line starts from here. It is parallel and it start keep moving, it keeps moving towards the points and keep moving until the loss is decreasing, until this loss is going down. This will keep moving, this line will keep moving. Okay, the moment it reach to a location where this error is not going down anymore and it again start increasing. Okay, the value of error, the loss start increasing, you can see the residue start increasing. That moment is the moment where it realizes, okay, it has crossed the best fit position, and it goes back to that position where the error was least and declare this point as global minima, that is the best fit line position. Now this line becomes the best fit line. This best fit line terminology means that this line is its best position, it has the least amount of error, possible error, from all the points at this moment. That is how we find the best fit line. Once we are done with this finding, we need to understand two or three things. These are, we have the equation of y equals to mx plus c. What does it mean? This is my slope, this is my slope, this is my x point, this is my intersection, and this is my output. Overall, it is called equation of line. Okay. Now, this m is basically the slope. This angle that from which we are moving the line, this angle is slope, and by as per the angle, it is moving. Okay, it is moving. And the moment it finds a point where the error start increasing, error start going up, this is the moment where it realizes that we have crossed the global minima, and we go back and declare this point, initial point, as global minimum. This point becomes the global minima. Global minima means it is the lowest point that has the least amount of error, and the best fit line will use this angle, and this will be our best fit line position 2. So this is how it is going on, and it will keep moving up if you go further. The error will keep moving up if you go further in this. Okay, so I hope global minima makes sense. And we can only control, or we can say only change and modify the value of m. X is input, we cannot do anything about it. Y is the output, we cannot really control that. An intersection will happen as per the angle of m. So m is the main thing and is the most important thing that we're going to focus on, and which will create all the moving part. Okay, which will help us to reach to the global minima.